Okay, so let's show how the target is created and connected. And on the left side, this is the machine that with the with accelerator card, which attached with 4 SSDs. But on the right side, there's an accelerator, but there's no SSDs attached to it. So on the left side, since there are SSD attached through the Slim SAS to the accelerator card, so we're going to show how the local target is created and connected. On the right side, we'll demo the functionality of the initiator. So as an initiator to connect the remote target created by the left side machine. And as we can see that there's no we actually have a on the left side we actually have a system SSD. Actually it's used for the system, but it's not the SSD that any SSD that used for the accelerator. So the accelerator there's actually 4 SSDs attached to the connected to the accelerator through the Slim SAS, but this is not the SSD that we have seen on the host for right now. So but we can see 4 controllers of the accelerator card of the 4 controllers, which are NVMe 1, 2, 3, 4. They are actually 4 controllers of the Resnics NOF accelerator card. On the right side, again, we don't have system NVMe SSD, so we directly see that the 4 controllers of the accelerator card. So we actually have a CPU in the accelerator card, and there are operating system on it. So we can use a vendor specific command to send shell command to the accelerator CPU. So okay, so like let's check if these 4 SSDs are connected successfully. Okay, as we can see that there are 4 SSDs connected to the accelerator card. Okay, but on this side we can check this again. Okay, so we can list the block. See, we don't have any SSD attached to the right side accelerator card, so we don't have any NVMe SSD. As we can see, there's no NVMe SSD in the accelerator card. So now we can initialize the NOF accelerator. First, let's check the network. Okay, so we're actually using the EVIO port as the data path for the NVMe OF. So let's configure the EVIO port with IP address and MTU 4200. So okay, at this side we configure it. Okay, so we can pin each other if we can see if the network is good. Okay, so the network is good, and now we have one more extra step to do, which is actually used for some PFC related register initialization, but this is just for demo. In the production, of course, we don't have such a step. Okay. And now we can create the subsystem. Actually, it means the target. So the commands to create the subsystem is actually the same as the commands that we use in the standard Linux kernel, like how you operate on those in the Linux to create subsystems. It's the same, but we wrap those commands into scripts. So for demo, we can use the script directly for simplicity. So first, let's create a local target, a subsystem for local connection. Now we have created a subsystem for local connection, and we can also create a remote connection. Still, we use a script. That means 4 disks, 1 controller, and the start namespace ID is 5. All right. Now we have created the remote target, which is a subsystem test NQN, and the local is local NQN. So on the left side, since the SSDs are attached to the accelerator on the machine, so we have to connect the local target. So, sorry, let's connect to the local target. We're using the loop transport address 1 local NQN. Okay, here we go. Let's check. Okay, so we can see that the 4 namespace attached to the controller 1, which is actually the first controller of the accelerator card. Now on the right side, we'll connect the remote target through RDMA. Sorry, A first. Okay, that's the IP. Test NQN, and we can use okay, 4 queues. Okay, here we go. Let's check. Okay, we can see that the 4 disks are added. There are 4 namespaces attached to the controller 0. Actually, the sequence is the same. Like this disk is they actually the same sequence. I mean, the on the right side, the NVMe 0 and 1 is actually the same disk of the left side's NVMe 1 and 1. So each disk is actually become a shared disk through the hardware. So actually, we can access the disk at the same time by 2 hosts. Right now, we actually can access by many hosts through the Ethernet switch. But here for demo, we only show 2 hosts. One is the local target, the other one is the remote, to connect the remote target. So, but to operate on the same disk, we need if we have to read-write the same disk, we need a we actually need a shared disk file system. But for test, we're using FIO for test, so we just test a different disk right now. So just for demo. So we can see that we can test the second disk on the local side, and we test the 4th disk on the right side. So yeah, we run them together. Okay, so this is a random read. This is a sequential read-write with 70% read. This sequential read-write with 50% read. Well, the right side's operating disk is faster because maybe the left side's running disk is a little bit more weird. Okay, this is a random read-write with the 70% read. So random read-write, 50% read. This is sequential write. Okay, this is a 4-key random write. Okay, so the tests are down, and we can see that the both sides we can test the different disk, but of course the disks even with the same test case, they have a performance difference due to some disk. They are like we're leveling background task in the disk. Something is different, so that's normal. Okay, so that's all for the demo.